Hi, this is video 4.4b, integrals of absolute value and finding areas using definite integrals. Okay, so integrals of absolute value. On page 293, you'll notice the last four questions are all integrals of absolute values. Okay, you can't just ignore the absolute value like it's not there. It obviously means something. And it all goes back to the fact that an absolute value is actually a piece function. So let's just take for an example, the integral from -2 to 3. I'll take an easy one, absolute value of x dx. What you have to realize is the absolute value of x is two different functions. If x is greater than or equal to 0, you can lose the absolute value signs and just keep x. But if x is less than 0, then when you drop the absolute value signs, you have to stick a minus in front of the x. So if I'm going from -2 to 3, I've got to break it up on either side of 0. So I have -2 to 0 plus 0 to 3. Now let's take the second piece. 0 to 3 is on the right side of 0, which means I can get rid of the absolute value and just put x. But when I'm between -2 and 0, I'm on the left side of 0, which means when I drop the absolute value, I have to put -x. You're actually integrating two different functions. So if I integrate -x, I get -x squared over 2. I'm evaluating that from -2 to 0 plus, and then I integrate x to get x squared over 2 from 0 to 3, plug in, subtract, blah, blah, blah. Okay, so remember, okay, and of course we're using this property. So here's number 24, the integral from 1 to 4 of the 3 minus the absolute value of x minus 3 dx. Okay, so they had to make it complicated. Okay, let's just look at the absolute value. On the side, the absolute value of x minus 3 is x minus 3 if x minus 3 is greater than or equal to 0, and negative the thing inside if the thing inside is negative. Simplify all this. That makes it x minus 3, this is 3 minus x. Isolate x, that means if x is greater than or equal to 3, and this is solves to be x is less than 3. So my cutoff point is 3. And sure enough, they gave me 1 to 4. So I have to split it up 1 to 3 plus 3 to 4. Now again, be careful. On the left side of 3, which is where I am when I'm between 1 and 3, I can drop the absolute value if I stick a minus in front of it and therefore get 3 minus x. So the green absolute value becomes this parentheses 3 minus x. This 3 and this minus is unaffected by anything. Okay? Then on between 3 and 4, when I'm on the right side of 3, now I can replace the absolute value of x minus 3 with just x minus 3. So you simplify this integrands, and then you integrate each one, evaluate, blah, 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 and you'll get whatever that answer is. Okay, couple of definite integrals now with trig. So if you integrate 2, of course, dx, you'll get 2x. And if you integrate negative cosecant squared, you'll actually get positive cotan. Because remember, the integral of cosecant squared is negative cotan. Reason, because the derivative of cotan is negative cosecant squared. And now you're evaluating from pi over 4 to pi over 2. You plug in the pi over 2 first in parentheses, minus, very important, this next set of parentheses. And then you replace the x's by pi over 4. And of course that requires you to know how to find the cotan of pi over 2 and pi over 4, but that's algebra 2. Your answer, either this one or this one, is a single fraction. Okay, area, back to area. Determine the area of the given region. This time the graph is given. They tell you the function. You can visually see left border x equals 1, right border x equals 2, bottom border x-axis, top border the function, and you actually set up integral 1 to 2 of 1 over x squared dx. That's x to the -2, integrated to get x to the -1 over -1, which is -1 over x. And now plug in the 2, minus plug in the 1, always top minus bottom, and you'll get a half. Here, numbers 1 through 4, this is an interesting one. Use the TI to graph the integrand, then use the graph to determine whether the definite integral is positive, negative, or 0. They're not saying if the areas are always positive. They're asking you if the definite integral is positive, negative, or 0. So very simply, if the shaded region is entirely or mostly above the x-axis, then obviously there's more positive stuff than negative stuff, so it'll be positive. If the region is entirely or mostly below the x-axis, there'll be more negative stuff than positive stuff, and therefore your answer will be negative. If the region is half above, half below, then your answer will be 0 because they'll cancel each other out. So here's an example, number 2. Integral 0 to pi cosine x dx. This is a TI-89 graph, but whatever. So this is the graph of y equals cosine x from 0 to pi. You can visually see that half the region's above the x-axis, the other half is below. And therefore, your answer will be 0 for your definite integral. If you let them both have the same area, the integral from 0 to pi over 2 is a1, but the integral from pi over 2 to pi is negative a2 because it's below. And therefore, when you add a1 plus negative a2, you're going to get 0 because a1 equals a2. Okay, this next couple of ones are not in the book, but they're very popular on the AP, and you'll see them in the DNS. This is very, 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 very popular, okay? It says, if f is an antiderivative of this function, they're not saying f of x equals, they would have said f of x equals, f of x is the integral of this function, okay? So little f is the integral of this function. I'm going to call it big F of x. And they give you little f of 3, and they ask you to find little f of 2. This is a really interesting problem because here's how it works. By the first fundamental theorem of calculus, if the integral of big F of x equals little f of x, then the integral from a to b of big F of x is little f of x evaluated from a to b, which is little f of b minus little f of a. So the integral of x cubed, sine x over x cubed minus 1 dx, they told us was f of x. F of x is an antiderivative of sine x over x cubed minus 1. Notice how I'm purposely going to go integral 2 to 3. This is not a fluke. I'm doing 2 to 3 because they gave me little f of 3 and they're asking me for little f of 2. That's one of the limits of integration, that's the other. So I'm going to use 2 to 3. Well, I know that means that that would equal little f of x from 2 to 3. Well, that means that on the right side, that's going to be f of 3 minus f of 2. F of 3, they told us, was 0.12478. F of 2, they're asking us what it is. And of course, on the left, I have a definite integral that I have a calculator, and I can evaluate that definite integral. And therefore, f of 2 is 0.12478 minus that, which is whatever number that is. Here's another popular AP question, and I'm going to show you at the end how you could do this super fast, but okay, it says if the integral from 0 to 5 of 7 to the x dx minus the integral from a to 5 of 7 to the x dx is 7.42, find a value of a. Well, the first thing to notice, it's the same exact function. Also, next thing to notice, these are both 5s. So what one way to do this is to switch this order and make it a to 5 by changing that negative to a positive. And then, of course, the integral from 0 to 5 plus the integral from 5 to a would be the integral from 0 to a. And then you can just solve that on your calculator. Okay? On the other hand, and this is how you can solve this on your calculator. You simply say solve, and then you just enter this thing exactly as you see it, comma a, because that's what you're solving for. But on the other hand, you could have solved the original thing they gave you on the calculator. You could actually have said solve integral 0 to 5, 7 to the minus a to 5 equals comma a, and you'd still get the same answer. You have a very powerful calculator. Numbers 39 through 44, find the area of the region bounded by the graphs of the equations. This time the graph is not given. You need to graph it, okay, and that's going to happen. All right, 1 minus x to the 4th. You should realize if I replace y by 0, this factors into 1 plus x squared, 1 minus x squared, which means it has x-intercepts at 1 and negative 1. And you should know it's kind of a skinny parabola turning down, and it got moved up 1. So it looks like this. And it says bounded by the blue curve and y equals 0, i.e. the x-axis. So it means this region right here. And of course, that'll be the integral from negative 1 to 1 of 1 minus x to the 4th dx. And then the rest is blah, blah, blah. Integrate, plug in the numbers.